So this is UX and APIs that developers and users love. And my name is David East. I'm a developer advocate here at Firebase. And it's kind of funny that I'm giving this talk, because it wasn't all that long ago that my idea of user experience was just completely wrong. At Google, we have lots of talented and motivating people who work on user experience. We have UX researchers, we have UX designers, UX engineers, and I get to work with these people on a lot of different occasions. And usually at the beginning of a project, we'll have a UX designer will come and they'll make a mock. And I'll look at the mock and I'll say, like, wow, this looks so pretty. And they usually look at me, and without fail, every time, they say, I don't make things look pretty. I make them work well. And this is when my idea of user experience started to change. I wondered to myself, well, what if user experience isn't just about thin fonts and different shades of blue? Because I'm a developer, and when I build applications, I think of things like this. I see my app as a series of views or network requests or threads. And my friends who work in UX, they tell me this is fine for your own mental model. But your user, they see things differently. They don't care about the code that happens behind the screen. Because everything for your user is a moment, whether they're creating an account for the first time, making a payment, or writing their first post. Each one of these things is a moment. And the important thing to understand about moments is that every single moment comes with an expectation. We expect to be able to create an account without seeing a dozen red boxes of information we need to fill out. We expect to make a payment without it being painful. And we want to write our first post with confidence. And if we don't get this right, we can give the user a 1-star moment. But if we understand their expectation, then we can give them what they need and give them a 5-star moment. So in order to understand what our user needs, we have to not just look at our applications as a bunch of code, but we need to think about our apps as a series of moments. Now, I'm not here today to teach you how to turn every single part of your app into a 5-star moment, mostly because I don't know how to do that. But I can help you look at critical parts of common applications and see how we can increase those moments. So I've been working on Firebase for over 4 years now, and I've given lots of talks: how to use Firebase hosting to build blazing fast websites, how to structure your data in Cloud Firestore. And these are all very developer-focused talks. But if you think why we want fast sites or why we structure our data in a certain way, we don't do it just so we can feel good about ourselves. Well, maybe a little bit, but we do it for the user. So maybe Firebase isn't just a development tool, because we can use it to make moments for the user better. So it also means we can look at Firebase as a UX tool. So the first moment I want to talk about is onboarding. To me, onboarding is really interesting because it's the first impression your user is going to have of your app. And this is a chance where we can show them that they are going to have a great experience. But that's not always what happens. If we don't really think about the user's perspective of onboarding, we could get it wrong. Because at this point, you have your user's interest. They are very, very excited. They've downloaded your app. They've opened it. They're ready to see the content or just use it. But what we show them is a wall. So in order to keep this excitement, we need to onboard them as quickly as possible and to reduce friction. And so in order to do this, we're going to have a lot of different features. We're going to have to allow them to log in with multiple different types of providers. We're going to have to show them that they can easily reset their password. And we also want them to be able to link different accounts, because we don't want them logging in with one provider and then coming back in and logging in with another and wondering why they have 2 different accounts. And this is something that Firebase Authentication does. There's multiple types of authentication with Google, Facebook, Twitter, GitHub. You can log users in with email and password. You can log them in even anonymously. So instead of having a UI that looks like this, where we just give the user one option, they might feel backed into a corner. And they might look at this and they think that this is a one-star moment, and they just bounce. So instead, we can give them multiple options. Log in with Google, sign in with email, or even your phone number, or just browse as a guest. But the problem here is that one of the most friction-filled parts of creating an app is having to think of a password. If the user wants to log in with the email and a password, not only is a lot of friction having to open up the keyboard, enter in an email, and enter in a password, but the user has to create this password in their head, know that they're basically going to forget it, and then have to reset it sometime in the future. So what would be great is we could log in a user without a password. What if we could just take their email and have them create an account? Well, recently with Firebase Authentication, we released a new feature called passwordless authentication. So let's see this GIF to see how it works. The user enters their email, they hit send link. All right, user enters in their email, sends link, and then they go and they check their email. They get an email from your app, and it comes with a sign-in link. So they tap it, and then it redirects them to the app, and it just automatically signs them in. And this is a great moment for the user, because it's one less step, it's one less password they have to remember, and we can get them into our app much faster. So this feature is available on Android, iOS, and the web. And this is a code sample of how we'd implement on the website. We started by grabbing a Firebase auth instance, and we call an aptly named method, send sign-in link to email, which takes in the user's email, and then some action code settings, which is just a bit of configuration. And since this method is asynchronous, we await it. And then we need to set the user's email to local storage, because we're going to need it later. And at this point, we can prompt the user, hey, go check your email. So the user will go out, check their email, and they'll click on a link, which brings them back to our page. And at this point, we need to check to see if they're coming in with this sign-in link. And we can do that with a little helper method from Firebase Authentication. We can call isSignIn with email link with the current URL. And if it is a sign-in link, we're going to get that email that we saved to local storage. Now, we want to make sure that this link is here, because if it's not here, we're going to prompt them again to make sure that we have it, because something could have erased it from local storage or some error could happen. So we'll just prompt them one more time to make sure we have it. And once we have it, we'll call sign in with email link, and we'll pass in the email and the current email link. And at that point, we'll just clean up after ourselves because the user's logged in. So in order to provide better moments for our users with onboarding, we need to give them multiple options so they feel more trust when they log in. And we need to reduce the friction so we are not trying to pull too much from them up front. Now, another moment I want to talk about is what happens when your app crashes. So the user's logged into your app, and we onboarded them quickly, but the next thing we know, the app crashes. And you might think that this is a one-star moment, but it actually doesn't have to be. See, this is a point in our app where we can show the user that we're humans and that we do make mistakes, but we work to fix them. But in order to fix things, we have to know where our app is breaking. We have to be able to properly monitor it. And this is something that Crashlytics does very well. So once you have Crashlytics set up in your app, you get a dashboard full of useful information. You get to see the crash-free statistics, which hopefully makes you feel good about your app. But when issues occur down at the bottom, we can see in which file the issue occurred, on what line of code. We can see how many times it's happened, and for how many users. So we can see what's going on and respond and fix it quickly. But you might not be refreshing this page every second of the day. So you want a way to get notified of this, or a way to handle this data outside of this dashboard. And Crashlytics has an integration with Cloud Functions. So every time a new issue occurs, you can have a Cloud Function triggered, and we can do something with this information. So to create this Cloud Function, we'll give it a name. And in this case, I'll call it post-on-issue-create. And then I'll set up an on-new-issue trigger. And inside of the callback, we get the issue information. And from here, I can really do whatever I want. I can send this information to Slack, so I get a notification that we're having an error. I could maybe send it out to a Twitter status to let our users know, hey, we have a problem, but we're working on it. Or we send it out to our own status page, or even an internal dashboard. Because it's OK when we fail. A lot of times when you do fail, it's a way to show the user that we're all human and we're trying to fix things. And it's a way to earn trust in your users, even though we had a crash. And Crashlytics gives you a lot of insight into these obvious one-star moments, where the app crashes, and it's very clear that this isn't a great moment for the user. But what about moments that aren't so obvious? What about the moments that lurk in our app and we just don't know about? And usually these moments are performance-based. Usually, we might work on fast computers, and we might always see fast connections to our app, but our users, that's not always the case with them. They might be on slower networks, and we're not seeing the same results that they are. So in this case, this is loading, and it's loading, and it's loading, and it's loading, and it's loading. Man, and there we have it. And for your user, these types of slow loads are really stressful. They're sitting there just waiting for the data to come back. And the problem is, we don't see this as app developers, but our users do. So how do we know these things are happening if they're not happening to us? And this is a case for Firebase performance monitoring, because it allows us to set up tracing in our app and see real-world data from our users. So once you have it set up, you get all this information in your dashboard. I can see traces by frequency, and I can see the network response latency from different countries. And something that I've noticed in this is that I have this one trace that's taking almost 7 seconds to finish. So I go and I inspect all the network requests that are happening in my app. And I notice that I have this one that takes about 2.15 seconds to complete. So I drill in, and I see that this is actually a Cloud Function. And in this response time box, I see it takes anywhere between 2 seconds to almost 5 seconds to complete. So why is this happening? Well, this was my fault. I was really excited, and I was using a new feature from Cloud Functions called callable functions. The way callable functions work is that we get a function name, and then we can create a new callable function. And a callable function takes in 2 arguments: data, which is the data the function is called with by the user or client, and context. And context is very useful, because if the user is authenticated, we automatically get their ID and other information about this user. And so now that I have this ID, I can just go out and get some data based on it. And callable functions just don't stop on the server side. There's actually a client SDK for Android, iOS, and web. And in this iOS example, I'll call a callable function by its function name. I can call it with any data I need. And then inside a callback, I can just bind that result to my view. So why was this slow? Well, this was the mistake I was making. I had to get all this data to the view. I was making 3 sequential network calls. And this one could take anywhere between a ½ second to 2 seconds. And then I would make this one, which is another ½ second to 2 seconds, and then yet again. So that's why I could see sometimes this could take almost 7 seconds. So I decided to trace this and fix it. So I create a custom trace and start it. And then I aggregated these 3 calls into one on the server side, So now instead of waiting for 3 calls, I'm just waiting for 1. And this might be a little faster, but it's still about a ½ second to 2 seconds, which I wouldn't really call that a 5-star moment. It's kind of like a 3-star moment. And the reason why it takes this long is because your user might be somewhere else on the other side of the world than where your server is located. And if that user is on a slow network, it's going to incur a lot of latency just getting to your server and back. This is something that you can solve with Firebase hosting. And traditionally, you might think of Firebase hosting as just a way to serve websites. But when you think outside of the box, you can use Cloud Functions and Firebase hosting together to create really fast REST APIs. Because with Firebase hosting, it's backed by a content delivery network, which means that we have an entire network of servers all around the world. So when your user needs a piece of data, they're not traveling all the way across the world. They're just going right up the street. So the server code for this is I switched from using a callable function to an onRequest function, so I can control the response. Go back. And so I set a cache control header, and it tells the server how long we're going to cache this on the network. And then I can decode the auth token using the Firebase admin SDK. And now I just need to tell Firebase hosting how to talk to Cloud Functions. So I set up a firebase.json configuration file where I just set up a server rewrite, and I say, whenever you see this path, call this Cloud Function. And I write Firebase deploy from the command line, and my REST API is available to the world for use. So I refactored my app, and I now just call this, make a network request out to my domain, and I wondered, just how fast is this now? So I waited a day, and I went back to the dashboard. So I filtered within the last 24 hours, and I saw that my network request went from almost 7 seconds down to 68 milliseconds. And that's how fast it loads. From a cold start, from the cold start of the app, the data load feels almost instant. And this is what the user expects. They expect to be able to load their app and see their data immediately. So in order to give a user great moments, we need to be able to monitor real performance, not just look at the performance we see when we develop, but the performance that happens in the wild. Now, my favorite moment is handling offline situations. Because when your user loves your app, they're going to bring it everywhere with them. They're going to bring it camping. They're going to take it on the plane. They're going to bring it to their friend's house that has bad cellular service and really flaky Wi-Fi. And despite these circumstances, we still want to give the user a great moment, even when we don't have a connection. And that's not really what happens in a lot of the apps we build, or a lot of apps we download. We want to use it, but when we don't have a connection, we just get some UI that says, like, hey, sorry, please find a connection and use this app later. And this isn't what the user is looking for. The user downloaded this app so they could use it, so they could view the content. And if we're not able to provide them with an offline experience, then it's a disappointing moment. And we don't want to just build read-only apps offline. We want them to be functional. We want to provide as much experience without a connection as we can with a connection. And the problem with doing this is that when we build our apps, we have to split everything up when it comes to data retrieval. So we'll have an offline cache of data for when the user is offline. And then when they go back online, we make network requests. And we have to synchronize this data with an offline cache. And not only is this difficult to architect in your app, it's difficult to architect in your brain, because you're thinking about the app in this offline state and this online state, and it's easy to create bugs, and it's easy just to get confused. And this is actually my favorite part of using Cloud Firestore. So Cloud Firestore is a document database that's really scalable, has a simple collection of data, and allows you to do powerful queries. But my favorite part is how easy it is to build offline-ready applications. So this is an app I made. It's a PWA, and I can use this camera app online just as I can offline. I save data, and it goes to my weird selfie feed. And all I have to do to enable offline is on the web, I just call enable persistence, and on Android and iOS, it's just enabled by default. But now, once we're offline, we have a new responsibility to the user, because behavior offline can be different than behavior online. So we have to build a UI that guides the user to make correct decisions. So in the case of this screen, I have all these pictures, but I don't know if any of these pictures are synced with the server. So I don't know if I can delete them or what, or if anyone else can see them. So I can use Cloud Firestore to help me out here. So I'm going to create a document reference. And so I'll go into the cities collection and grab the document of San Francisco. And then I'm going to add a snapshot listener. And every single time this document updates, this snapshot will fire with this on-event listener. And using this data snapshot, I can actually go in and get the metadata of this object and see if it has any pending writes. Because if it has pending writes, then I know that this is local-only data. And if it doesn't, then I know it's been synchronized with the server. And so using this, I can change my UI, and I can add some opacity to the images so the user can see that they aren't synced yet. And then when the opacity changes, they know that their data is now backed up. And this is great because we're giving the user proper guidance. We're giving them an offline experience, but we're letting them know what's happening while we're offline. So a lot of the topics I've covered are about bringing expectations or understanding the user's expectations. And we want to meet the user's expectations. But every now and then, we get to go beyond the expectations, and we get to surprise the user. So not that long ago, I bought a house. And the really interesting thing about buying a house is that once you buy it, everything breaks. And so my hot water heater broke pretty much the first week I moved into my house, and I had someone to come out and take a look at it. And I noticed when they were inspecting my hot water heater that they were taking a picture of it with a custom app their company built. So I asked him, hey, is this useful for you? And it was surprising because he looked at me and said, no, it's not. In the past, before I had this app, I just wrote down this manufacturer and the serial number of the hot water heater, and I was done. But now I have to open this app, take a picture, and I still have to write down the same information as before. And I kind of thought, like, this is a moment where we're not meeting the user's expectation. We're actually making things a little more difficult. So when he left, I went upstairs and I got to work. And so I built a little app using MLKit. So we launched MLKit at the beginning of this week, and MLKit is a tool to bring machine learning to mobile devices. And so I created a vision text detector, and then I grabbed a UI image from the view, and then I converted it to a vision image. And using that, I was able to detect any text that was in this photo. And in case you thought that this wasn't a real story, this is me. Oh, we go back here. Can we roll the video? This is me in my basement, scanning the serial code number of my hot water heater. And you can see that in real time, I'm picking up the text. And then once I see the code is right, I take the picture, and then I didn't have to write this information down, and I get the picture and the serial code number all at once. Can we roll forward? And this is what the user wanted. They didn't want 2 steps. They wanted to have the picture and the serial code number. And this is something that's going to happen for the user multiple times a day. So while it's small, it has a larger impact and it just makes their lives just a little bit easier in this unexpected way. And so throughout all this process, I thought to myself, UX isn't about your fonts. It's not about your layouts. It's not about what color blue you pick. User experience is all about the moment that a user goes through. And in order to really give the user a 5-star moment, we have to think about their moment and think about our developer tools as a way to create better moments for our users. So your feedback for this talk is really important. So I know you've probably heard this in every single session, but if you have any feedback, visit the I/O app and leave that. That'd be amazing. And I'm going to be at the Firebase tent after this, so if you want to stop by and ask any questions or take an offline selfie, I'll be available. So thank you all so much for coming out.